All right, so the last talk of today is going to be presented by Andy Grant of Zoom. He's going to be talking about TCC and some interesting vulnerabilities and bypasses in that.
All right, yeah, thank you. So I'm going to talk about some TCC research that I did. So back in 2019, I disclosed a series of security vulnerabilities within package installers to Apple. They allowed an unprivileged user to execute as root arbitrary code. During the reporting with Apple, I explicitly stated that it allowed you to execute as root, and Apple responded back with, "What's the impact?" Do I need to explain what root is to Apple? I quickly and hastily shot back a response of, "You're root. You can do anything you want, including bypassing TCC." Then I kind of had that moment of maybe I spoke out of turn, and I should probably make sure that's true. And so I was eventually able to show Apple that it was true, that as root I could bypass TCC back in early 2020, and now I get to share it all with you. So I've been poking around computers and doing offensive things for over 2 decades. I started out cheating at video games, went and got a computer science degree at Stanford University explicitly to become a better hacker. I got to work side by side with some of the world's best in the industry at ISEC Partners and NCC Group, and eventually now work at Zoom, where I'm building out the offensive security program. Along the way, I managed to set American records and ended my swimming career ranked top 25 all time for the US. And according to playerwives.com, you should all be very impressed with that, except I married Dana Vollmer, and proudly so, I will forever be known as the +1 to a 5-time Olympic gold medalist. So first, I'm going to make sure we're all on the same page, give a little background about macOS protections, SIP, and TCC as the focus. And then I'm going to walk through how I circumvented some of those restrictions. And to wrap it all up, I'll cover how you can use that same technique to get a free cloud-hosted macOS VM. So first, the protections. In Unix-like operating systems, security policies are enforced by discretionary access controls. This allows users to override the security policies according to their preferences, and as such, root can do just about anything on the system. Apple has decided that this doesn't make for the best user experience and instead added mandatory access controls. This allows for creating policies that cannot be overridden. Mandatory access controls aren't directly visible to the users, but you probably have encountered them through many of their modern security protections via their sandboxing, parental controls, managed preferences, and system integrity protection, or SIP. Since root on macOS is no longer root in the way we expect, the term rootless has become used to describe modern macOS systems. With the addition of the M1 chip, Apple has even brought over kernel integrity protections from the iOS platform into macOS. This provides hardware-backed protections against modifying parts of the kernel during runtime. In addition to a major focus on security, Apple has a lot of focus on privacy and a user's right to control their data. This has led to the development of their Transparency, Consent, and Control System, or TCC. This is the macOS version of Windows UAC, or User Account Control, and is responsible for the pop-ups and on behalf of apps and processes requesting permissions to your data and various resources. It was first introduced in Sierra, and its scope was fairly limited and really focused in on system-wide access, such as accessibility or full disk access. There was a fairly significant jump in TCC's coverage during around Mojave, where a user's personal data, documents, desktop, calendar, was added, as well as access gating for camera and microphone. One interesting tidbit I learned through this research is that a user's trash is even extra protected, that even with SIP disabled, even with full disk access, you cannot access content within a user's trash. If you want to programmatically interact with that, you have to remove it from the trash before interacting with it. And the user doesn't even get a prompt. There's no access you can grant. As is often the case with Apple's proprietary services, there's not a lot of great documentation on it or any official tooling. For example, there's only one official command line tool for TCC, TCC util, and it only supports a single action, and that's to revoke or reset a permission granted in the TCC database. TCC is backed by SQLite databases, one for the system protections such as full disk access, accessibility, and similar permissions, and one per user for the user-specific access such as documents and desktop. Being SQLite databases, they were initially able to fairly easily programmatically interact with them just using SQLite, and you had minimal permissions necessary to do that. But this was infamously abused by Dropbox, and now access to the database requires full disk access permissions to begin with. Furthermore, the system database has the additional protections of being SIP protected, so even with full disk access, you cannot write to it unless SIP has been disabled. For a while, there was a commonly known way to circumvent TCC using SSH. In order to facilitate remote login, logically, macOS automatically granted sshd, or specifically SSH key wrapper, full disk access when remote login was enabled via system preferences or the command line tool system setup. If you were running as root or knew an admin's password, you could enable remote management via this SSH in to the local host, and you instantly gained full disk access. And this would allow you then to inject into the user-specific databases and gain more access or add access to other parts of the system. However, Apple has grown wise to this, and since Catalina, you have to have full disk permissions enabled to call system setup to enable this SSH. And so to gain your full disk access, you have to already have had full disk access. So let's talk about bypassing some of these. Before doing that, let's see what it will actually look like when we achieve this. So here we're running on Big Sur, the latest version at the time, and I'm going to demonstrate that terminal does not have full disk access by trying to read from the system database. I get denied. I'll run through a simple package installer. So it runs with root privileges because I typed in my admin. When this installation completes, we will then try that command again, and we were able to read from the database. So we now have a terminal with full disk access, with no user interaction besides running the installer. So to set the scene, even running as root, you can't do everything you might want, either because of SIP or because of TCC. You can't directly give yourself more permissions unless you already have fairly significant permissions like full disk access. If you are lucky enough to find yourself on a Mac with remote login already enabled and you know credentials to log in, then you can use the SSH trick. But otherwise, we need a different way to get this TCC permission. So this bypass begins with the assumption that you are running with root privileges such as installer, but you otherwise don't know an admin credential or have a way to interact with full disk access. So you're running as root, but you don't have full disk access or no credentials to the system. Management has shown me that OKRs, or objectives and key results, drive success. So we'll start out achieving this with an objective. Grant an application of our choosing TCC permission of our choosing. What key results will help us get there? Well, without a bug or exploitable vulnerability, this is supposed to require an admin physically clicking buttons, and thus we need to know an admin's password and have access to the UI. So that means remote management is enabled because we want full disk access as our end goal here. Unless SIP is disabled, getting the SSH access only gives us so much, and we can't add other things to the full disk access. Obviously, we're going to want to achieve this without any consent prompts or otherwise notifying the user of our activity. And ideally, our stretch goal here is to automate this whole thing. Since I'm a manager these days and no longer an actual hacker by trade, I'll follow the rules and arguably achieve this via malicious compliance and maybe a potential oversight in the system, but not exploiting any real vulnerabilities here. So first, we need an admin user. Well, we're running as root, so let's just create one. The normal Unix commands to do so aren't actually there on macOS. You can try add user, user add, not present. Instead, macOS has the system admin control command line tool, which will successfully create us an admin user, but it's kind of noisy. It creates a user, but it fires up a consent prompt along the way asking for the user to grant control of the system to the process. Notably, even if that permission is denied, the admin user was still created, but we alerted to the user and we're trying to avoid those consent prompts. So instead, we'll use the directory service command line tool. So we'll create a user, we'll give that user a password, we'll set the name for that user, we'll create a home directory for the user, we'll give them a shell, we'll add a user ID for them, we'll give them a group ID and choose the admin group ID on macOS, and then finally we'll add them formally to the admin group. Along the way, there is no need for full disk access while doing this, and there was no consent prompts or anything that alerted the user to our activity. Now, we started with the assumption that we're running as root, and now we have an admin user. So we didn't really gain a whole lot of privilege here unless we had a way to interact with the user interface. Now we have a password that we could type in for admin password prompts. But we kind of just walked through that you have to have full disk access to be able to enable that, and so we're kind of in this place of where do we go next? Well, it actually turns out you need full disk access to enable remote login, but you don't need full disk access to enable remote management or screen sharing. You can do this via the kickstart command within the Apple Remote Desktop ARD agent, and you can activate it for all, enable screen sharing for all users on the system, or if you wanted to be extra stealthy, you could do it for just the newly created admin user. Again, this did not require any full disk permissions, and it did not require any consent prompts to the user. Well, apparently Apple doesn't think enabling remote access via the command line only is a great idea, and it tells you this won't work. You get this warning that it will only work if you enable it through system preferences. Fear not, sometimes a warning is actually just a warning, and if you take one thing away from this is when you're hacking, ignore the warnings. HR disclaimer, when you're managing, don't ignore the warnings. Even with this warning being displayed, running this command on macOS 10.15 Catalina does in fact enable remote management with all the necessary permissions that you need to do what we want, connect remotely and engage with the system. However, in macOS 11 or Big Sur, this warning does mean something. While running the command does start up the remote management services, particularly the screen sharing agent, it does open port 5900, and it is reflected within system preferences sharing. You'll see the checkbox next to remote management. However, in Big Sur, Apple added just one more thing. In Big Sur, there are default deny entries within the system TCC database that deny the screen sharing agent the post event or accessibility equivalent and screen capture permissions. When you enable remote management via system preferences, TCCD grants these permissions to the screen sharing agent. But if you enable it through the command line, no such activity happens and you have these deny entries. Without them, your port's open, the services are running, you can still connect to the screen sharing session, but without the screen capture permission, you get a black screen. And without the post-event permission, your keyboard events are not affecting the remote system. So at this point, my TCC bypass works on Catalina, but not on Big Sur because of these deny entries. Well, if these deny entries are getting in our way, let's just get rid of them. So we have this TCC util command, we're running as root, we can reset these permissions and remove the entries from the database. So without these denies within the database, our remote access is restored and we can proceed with connecting and granting our payload permissions through interacting with the UI. So if there is a bug throughout this whole process, it's probably this. The screen sharing agent, for screen sharing agent, TCC is acting as a deny list instead of an allow list like we come to expect it for everything else. The screen sharing agent appears to have post-event and screen capture permissions unless it's explicitly denied. In the end, I actually only need post-event permissions is I found a way to do this all blind without being able to see the UI. And so we can leave screen capture alone because the way in which TCC util works, the bundle ID for screen sharing agent isn't recognized by Apple as a valid bundle ID, and so I can't reset just those permissions. I would blow away all the screen capture permissions for any app installed, which could be disruptive for if you have a Zoom application installed and you try to do screen sharing through that. So at this point, we've satisfied all of our key results. We use the directory service command line tool to create an admin user, and we now know admin creds on the system. We then use the remote desktop, Apple Remote Desktop Kickstart command to enable remote management. And then we also reset the permissions for the post event. We did this all without any consent prompts to the user and without any additional permissions. Now, to make this a proper bypass, I wanted to automate this as we saw within the demo. The automation actually happens via a script to send keyboard events over a VNC connection, and the ability to navigate the modals via keyboard, so I don't even need to use the mouse or be able to see the UI in any way. Thanks to a suggestion of one of my team members, we even do this without any network activity by using the loopback interface, allowing this to fit neatly inside a purely local install package. Since we created a new user to do this, the automation of the remote access was initially a bit tricky as the user hadn't gone through the setup agent. This is, enabling analytics, iCloud, do you want to enable Siri, do you want light or dark mode, etc. To help with this, I added the ability to skip all of that setup flow, so when you connect, you automatically end up just right at the desktop and don't have to do any of that configuration. There may be a cleaner way to do this, but for now, I do it by just creating the user's directories all the way through to preferences, making sure the user owns those directories since I created them as root, logging in through an interactive shell as that user, let it run off in the background so I can keep going, and then writing a few dozen entries into its defaults for the setup agent, the setup assistant. This says, I've already selected whether I want Siri to run. I've already chosen my light dark mode and such. So now we've walked through that. We're really just automating the UI. So let's see what that looks like here. So on the right-hand side, we have the exploit and the demo we ran. And on the left-hand side, I'm going to connect to that system and then hands-off keyboard watch what that automation script is doing in the background. So we'll connect as the newly created user and then just watch what's going on here. We're first going to open up the Finder to go into the terminal application, load up terminal application, and then launch a file I created to jump us directly to the privacy panel within system preferences, easing the number of button clicks here. We're going to tab around until we get to the lock icon, type in our our admin password here, tab around until we get to the plus icon, and then we're going to select the application we want, terminal in this example. So terminal was open, so it asked if we want it, and there we have it, terminal added to full disk permissions, and that's all running by this installer on the right-hand side. The installer then goes through and logs us out, kills that user, and resets the thing, and we now have full disk access for that terminal application. So, as all of you all here know by being at this conference, macOS hacking is pretty awesome, but only if you have a Mac to hack on. If you don't have one, they're kind of expensive to obtain. You can go buy hardware, but Apple's hardware is fairly expensive, and the cloud-hosted offerings through AWS or Mac Stadium or similar are pretty costly for just playing around with. Well, we're in luck. GitHub actually provides free macOS and Windows and Ubuntu environments for running what are called GitHub Actions. At the moment, Big Sur has been moved into a private preview because the demand for it was fairly high, but you can still get a Catalina VM. Now, the systems aren't the most powerful, but they do have 64 gigabytes of RAM, which isn't too shabby, and they come really loaded from a developer's perspective with the most common package managers like Homebrew, a plethora of programming languages pre-installed, basically every Xcode and SDK from the past couple years, and And it's completely free if your action is for a public repository, and it's time limited if it's a private or enterprise repository. So here's an example of a GitHub action workflow. It's a YAML file that defines the workflow name, in this case macVM for me. It says that I'm going to use the bash shell to execute my action within, and then I specify that I want the latest macOS operating system to run on. And then I say the command we're going to run is sourcing in a shell file, and so that shell file will have the commands I want executed. The caveat here, though, is this is a headless system. It's not meant to be interactive. It just executes the defined action, and then you can watch the console output for standard in, standard out, and error messages. And so it's kind of like running a Jenkins job or similar. You're not getting that UI interaction. So we'll just add that interaction. We'll create an interactive environment here. So we create an action that leverages the steps that I walked through for the TCC bypass, but add in a reverse proxy. We don't want to automate the interaction. We want to be able to connect to it. So first we go through and create the admin user so we have credentials to the system. We enable that remote management and set up a reverse tunnel so we can connect to it. This will also serve as our blocking process within our workflow so the VM stays alive until that reverse tunnel exits and the script is allowed to finish. Now you can go and connect to your reverse tunnel using VNC, and you have your very own macOS playground. And this is what it will look like. So here we're at GitHub. We're in kick off our workflow. And then once this workflow starts, we'll click into it, go to the console output that GitHub provides. My script will ultimately print out the endpoint of that reverse tunnel. I use ngrop to simplify my demo here. Copy and paste that endpoint out, switch to our VNC client, log in as our newly created admin user, and then we'll find ourselves within a cloud-hosted VM that I'm not paying for. And so there's just evidence of all those Xcode versions and everything on there, and PowerShell and whatever else you may want. So to recap here, we started as root, but we didn't have access to an admin user or the UI. We created an admin user and used the CLI to enable remote management while also resetting the TCC permissions that would deny the screen sharing agent the ability to control the system. At this point, you could open up a reverse shell and manually interact with the system, including granting anything you want TCC permissions. But to make this a full proper bypass, we automated it. Using a VNC automation script, we connect to the screen share via the local host so we don't have to worry about their firewall, we don't have to worry about network activity or monitoring, and we log in as the new admin user. The script mimics the keyboard events that you would use as a manual user to open up system preferences, go to the privacy panel, and unlock the admin panel. Once you're there, you can then select whatever payload you want for whatever permissions you want. In our demo here, we chose to give the terminal application full disk access. And that is the walkthrough of why root, even just once, can bypass TCC permissions on a macOS system.